Yo, what's up, students? We're gonna be talking about rigid motions. Rigid motions are transformations which keep the shape and the size, which basically mean they are congruent. So let's say a rectangle. Let me draw one rectangle to this rectangle. Let's say I uh, rectangle A, B, C, D is transformed into A prime, B prime, C prime, D prime, not a B. Right. We need to find out how we can do this into this. We know that rigid motions means you cannot change the shape or the size, right? This is not this, and this is not this. Okay, with the use of our trusty friend vectors, we can prove congruency even if we don't have numbers, like on a coordinate grid. Okay, we have vectors A prime, vectors B prime, vector C prime, and vector D prime. Choose any of these. I'm gonna choose D because I like the D's. Um, there's no implied things based on that. Don't don't think of anything. Um, so we could say A B C D is translated. Translated because this is a translation, obviously, not a rotation. Students, make sure you know that is translated across D prime. I said so. To map onto A prime B prime C. Oh, what the C prime D prime. Uh oh, yo, my mic, my mouse onto A prime B prime C prime D prime is to map onto. Oh yeah. No, wait. Vector. Don't forget. Because translations are rich. What is happening? Our rigid motions A, B, C, D is congruent to A prime, B prime, C prime, D prime. Right? Make sure you're putting the pre-image vertex to the image vertex. This is the pre-image, which we start with, and this is the image, which we trying to get into. Pause. And so we can do this to prove congruency off the coordinate grid. So that's the first part of the lesson. Okay, now we're going to be talking about things on the coordinate grid, translations on the coordinate grid. Let's say we have a coordinate grid. Oh, purple. And we can say this is W E R D, stands for weird, right? Now we want to translate it across to, I don't know, over here. Translate across. Now, since we have a coordinate grid, we can say we don't need some vector. Those are weirds. Actually, vector. We need a vector, actually. So, vector. And let's say, since, okay, let's say -6, 5. This is W. Vector, and this, and then wait. W is, say, -4. these are the coordinates -2. And so if we want to go jump from here to here, -6 to -4. What is that? That is a 2 2 to the right. So that would be +2, right? And now from 5 to -2, that'd be a -7 decrease, which means 2 to the right and 7 down. That's how we prove this. Now we can say that, yeah, that WERD, weird, is translated across vector to -7. We don't have to use that weird whatever vector now. We can use this. And now this is just basically saying you're moving 2 to the right, 7 down. Up onto WERD. It's translated across to map onto, because translations are rigid motions. WERD is congruent to WERD prime. What changed when we went on the coordinate grid? We now have coordinates, and so we can use vector whatever numbers to prove congruence instead of vector. Let me draw this out. Vector instead of, I don't know, vector WW prime instead of that. So that's how you prove that. Also, remember that how you write translations basically are through this, and if you want to write translation, it's gonna be, okay, there will be 2 -7. It looks like this.